All right, here's the solutions for 4.3. Again, we're distributing. Whether you like to use the technique that some people call FOIL or not, that's up to you. By now, a lot of you already have a technique that works for you, but I'm going to demonstrate this as distribution every time. So I'm distributing 3v plus 1 to 2v minus 5, and so that's why I've set it up this way. Don't forget to distribute the negative. That's probably the biggest mistake I see in these problems. So I end up with negative 15v minus 5. And then I combine like terms and give my answer in descending order. Again, I'm distributing 2x minus 3 to 3x plus 2, so that's why I have it set up the way I do. Again, just be careful with your multiplication, be careful with your distribution. Combine like terms and write your answer in descending order. Again, it's the idea that I'm distributing 4z plus 3 to 3z minus 4. Again, be careful distributing your negative. Make sure you've got a negative 12. Combine like terms and write in descending order. Again, this is the time that I'm expecting things to really be written in descending order as opposed to when we see multiple variables. So again, r minus 4 is being distributed to 3r minus 2. Be careful distributing that negative 2. Make sure you end up with the positive 8. Now we see multiple variables, and the nice thing about the distribution technique is that this should already set our problem up in descending order. So I'm distributing 2p plus 3q to 3p minus 2q. Again, be careful when you distribute the negative. Make sure you end up with a negative 6q squared. And if I'm going to follow descending order in the alphabet, I'll end up with 6p squared plus 5pq minus 6q squared. 17, some people might recognize this as the difference of squares and go straight to their final answer, and that's all right if you know your difference of squares rule. Similar in number 19, if you know your square rule, it's up to you. But I'm distributing x squared minus 3 to x squared plus 3. My middle terms will add up to 0, that's why we call this the difference of squares, and I end up with x to the 4th minus 9. Similarly for 19, there's a pattern that's going to allow some people to go straight to their final answer, but I think for most of us we're going to take the time to write out s cubed plus t cubed twice since we're squaring it, follow through on our distribution, and come up with our final answer. All right, 21, it's up to you. You can multiply the first two terms, or you can multiply the second two terms, or if you wanted, you could multiply the first and the third, but we're not going to distribute the t to both binomials. We're only going to distribute it to one of the binomials. So I went ahead and distributed it to my first term, got t squared minus 2t, and now I'm distributing t squared minus 2t to t plus 1, continued my distribution, ended up with a like term in the middle, and I've got my final answer. Similar for 23, before we go ahead and do any of the distribution, we should write out the x minus 1 quantity squared first. If you want to multiply these two together first and then distribute, that's up to you, but we can't distribute the xy into x minus y quantity squared until it's been either multiplied out or rewritten as two separate terms. So I went ahead and distributed into my first term, getting the x squared y minus xy squared, and then that's the value that I distribute to x minus y, getting me my final answer. Again, be careful distributing the negative, make sure you have a plus xy cubed. Now 31 is an example of why we need to think of this beyond just that FOIL technique that so many people learn, because that technique does not work as soon as I end up with a trinomial. So it's the idea that I'm distributing the x squared minus x plus 2 to all three terms, x squared, x, and negative 1. Again, if some people want to go ahead and use the technique where they draw the arrows to each term, if that works for you, you don't make many mistakes with it, that's fine. But mathematically, what's happening is distribution. And so I distribute my terms. X squared gets distributed, x gets distributed. Be careful distributing the negative 1. Notice all three signs have changed. And then it's a matter of looking for like terms and combining like terms. Now, 35 demonstrates exactly what our rules are doing, but doesn't make a difference whether we're dealing with values or variables. So again, some people are able to go straight from the original value to the final answer because they know their rule for quantities squared. But I think for most of us, we're going to take the time to write the term out twice. I distribute my Pn minus 1 to both terms. Be careful distributing the negative 1. Notice that becomes a positive 1. Pn times p to the n times p to the n is going to get me p to the 2n. I have my two like terms in the middle, and I've got my final answer. Again, hopefully this helps. If it doesn't, feel free to ask questions in class.